This week on Maker Update, remote control snow patrol, cleaning up after Wally, fighting plastic with plastic, and a boogie-down Bottango bot. Hey, I'm Donald Bell, and this is Maker Update, our weekly show filled with new and notable DIY projects to help keep you inspired. I hope you're doing well. We've got a great show for you. Let's get started with the project of the week. It's been a hard winter for a lot of people, and if you're somewhere that gets snow, the novelty of it is probably lost on you at this point, and you're ready for it to go away. Well, thanks to Willem Smith, you've got a way to remotely clear some of it from the comfort of your home. This is a 1/7 scale 3D printed tracked remote controlled Snowcat. It runs on a pair of brushless DC motors mounted into high torque gearboxes. So the main chassis essentially runs like a rugged RC tank. You wouldn't want to sit on it, but there's a video showing that this thing has enough torque to pull someone on a sled. It's crazy. My favorite part though is the articulating plow on the front. This thing uses a total of 9 remotely operated linear actuators. There are some beefy ones to control the height and angle of the blade, and then there are some smaller ones to move the wings on the side to define the shape of the plow. Whether or not this thing proves to be a practical tool for managing snow, it looks like a lot of fun. All in, the parts and printer filament will set you back around $600. Plus, the plans and files will cost you another $120. Still, I've never seen anything like it, and if you're a snowbound maker with some money to burn, this project may be the perfect fit. More projects. From plowing snow to vacuuming dirt, we've got a project from Kiara's workshop on how she made a real-life mow robot from Wally that really vacuums. Well, sorta. From a remote-controlled replica perspective, Kiara really nails it. Mow looks great, and the head movement, the pop-out light, even the little water tank on the back. It's Mow, but in the real world. The problem is that designing a working vacuum is hard. It certainly helps that most of the vacuum components from this build are repurposed from a brand new vacuum, but even store-bought vacuums are famously temperamental. They clog, they bind, they lose suction. That it even worked at all is pretty amazing. In fact, there may never be a perfect vacuum. I think the potential with something like Mow is to have a robot vacuum sophisticated enough to repair itself every time it breaks. In a perfect example of designing for failure, Angus from Maker's Muse has a new video up on 3D printed combat robots. And unlike his previous work, we're really talking about a nearly all 3D printed design. This is a new category for combat robotics called plant or plastic ant weight class robots. Robots can use off-the-shelf motors and gearboxes as well as metal fasteners, but everything else, including the weapon, is plastic. The big appeal here is a low barrier of entry in terms of cost, but also you get to quickly learn what works and what doesn't and rapidly update your designs with minimal time and money invested. Angus shares the details and strategy behind his design for Violent Crumble, and with the limitation of plastic weapons, there's an interesting opportunity to explore methods for maximizing the strength of your 3D prints. Finally, for a robot whose only job is to make you smile, I've got a new guide on Instructables for making this 4-leg animatronic droid. The design was inspired by Aj and his Comet Crawler robot and uses a body design from Javier Isabel. Mostly though, I wanted a platform for creating my own custom animation sequences using Bottango, a free animatronic editor you've heard me mention many times before on this show. I'm happy with the result. I wanted a robot with personality, and that's what I got, along with a much better understanding of how to animate servos. As usual, you can find links to all these projects down in the description. Now for some tips and tools. On his website, mitxela shares a video and CAD files for a series of laser cut screw and nut counters. There are fancy professional ways to dispense hardware, but I've never seen a method as fun as this one. You load the hardware, give it a jiggle, and just pull the trigger to drop the measured amount into a container. If you want a bigger hopper or to dispense a different amount of hardware, the design is easy to modify. On his channel, Vman Builds has some useful advice about what pins to avoid on the ESP32 DevKit CV4 board. This is a super popular board format with some very sneaky issues that can be hard to diagnose. At first glance, it appears to have a relatively luxurious amount of general purpose I/O pins that you can connect to your project, but the reality is that only around half of these pins can reliably be put to work as both inputs and outputs. And there's no good way to tell those pins apart just by looking at the board. Some are input only, some are tied to system functions that may interfere with operation, and some pins are designed to go high or low during startup and may trigger connected LEDs or relays or motors in unpredictable ways. If this is a board you find yourself working with regularly, I recommend giving the video a watch and maybe screenshotting some of the diagrams to reference later. And here's a fun one. On Adafruit, John Park has a guide for building this arcade-style Fightstick game controller. Not only is it something cool to make and use, it's also a really useful case study on designing large 3D printed enclosures. For example, in order to hold up to all that button mashing and joystick hadoukens, the enclosure needs structural support all through the hollow midsection. To make this happen, John strategically places a series of interlocking pillars. Along the edge, you also have places for the top and bottom panels to screw onto the main chassis. It's a smart design, easy to repair, and I expect it'll hold up to abuse. For this week's DigiKey Spotlight, check out the latest video from Becky Stern on gadget teardowns and recycling. Tearing apart an old broken gadget is a great way to educate yourself on how manufacturers balance cost, function, and durability. More than that, it's really the best way to discover design techniques that can lead to improvements in your own projects. As a bonus, you can usually scavenge some decent electronics you can reuse in the future. Becky's video offers some great tips on making the most of your teardowns. Don't miss it. And that does it for this week's show. Be sure to subscribe, leave a thumbs up, leave a comment if you can. A big thanks to DigiKey for making this show possible, and thank you for watching. I'll see you soon.